Evo, did we do a chair stack? I don't see it.
I didn't do a chair stack, no.
You're unintelligible. Speak again.
I did not prepare a chair stack.
Okay, so we're going to do this without. Welcome to COSE. There are a number of interesting topics we have today. We have Lucas volunteering to take minutes for us. I am still looking for a second person that's willing to backstop Lucas as we go. Karen raised a finger, so thank you, Karen. So it turns out that not only are 3 presenters missing decks, the chairs are missing decks. And so, Ivo, is it possible to present or to project the agenda?
Sure. Let me give me 2 minutes, and I will probably just present a modified version of last slides. But yeah, just a moment.
Okay. Well, there we go. A screen share is being started.
Yes. Show.
Do I have to do something to approve it?
No, let me see too many windows.
Well, I will remind people, you've been here many times before in many other meetings, that the note well applies. Treat each other with respect and in a productive fashion. Well, there we go. We have a chair stack. So next slide, Evo.
Yes. So I guess that's what you are saying.
This is the note well. Next. All of you in the room, please do sign into the on-site tool. We will be using it to manage the queue. I know you will all want to speak up at different points. So thank you. Next. We have note takers. All right. So this is the opening remarks. We're not going to take 15 minutes. The C509 test vectors, the authors notified us that there hasn't been significant updates since we last met our heroes. Therefore, they didn't feel that a presentation was needed. Test vectors are straightforward and useful things. Any of you with implementations of C509 are highly encouraged to test the test vectors. Beyond that, would anyone, including remote participants, like to say anything about the test vectors? All right, hearing none, we will move on to post-quantum land. So, Ivo, can you stop sharing and I will share Hannes' deck. And Hannes, I'm going to give you control over the slides if you would like it, or I will advance it.
No, it's fine. You can do the clicking. It's good.
I can do the clicking? Okay.
Yeah.
Take us away, Hannes.
Yeah. Thank you, Mike. Thank you, Ivo. Hi, everyone. I hope you can hear me well. This is a short update of two of the documents. We talked about them at the last IETF meeting when I joined as a co-author of the document together with Mike Burrock and Ori. I think Ori is in the room as well. So
Ori is in the room.
okay, perfect. Next slide. So a quick update of what has happened since the last meeting. Primarily, the changes concern implementation activities for both of the documents. Specifically, I wanted to have some working examples in both of them. Currently, the change is focused on the COSE version. I haven't worked on the Jose version yet, but I think that's at least a start. I also implemented the MLDSA to just make sure that I have the sort of the whole bundle, and you can find the code here. It's based on COSE, which you all know, Lawrence's implementation. So while this is not really, I wouldn't really call it a lightweight implementation, which is what COSE is really aiming to provide because of the crypto library it uses, but it's good enough for the examples. Right. There's one aspect I want to point out for the COSE SLH DSA. I currently only have a single example in there because of the size reasons. I could add more if size doesn't really matter much, just to have something implementers can sort of work with. But yeah, that's what it currently is. Next slide. But since I have a time slot to talk about the documents, I wanted to sort of look at some of the design decisions in the past, and specifically wanted to ask the question, are the algorithms that we register enough or the right ones? Because just this week we had a discussion in the Jose working group about the number of algorithms that we register, and ideally we want to have as few algorithms registered as possible to increase interoperability. But of course, we don't want to miss out on some other important algorithms that people wanted to use. So that's why I've added these slides. I don't expect anyone to have an opinion right now while I'm giving the presentation, but I think these issues typically come up during the lifetime of the draft process. So I thought it would be good to talk about them again. Okay, next one. So, and I also wanted to put this a little bit in sort of the algorithm number in context of the developments in the LAMS working group. And here specifically relevant is RFC 9909, which registers the counterpart for SLH DSA for BKICS. And also relevant is, which I will talk later, is the question about what precisely do we sign? Do we sign the whole message, or do we sign a hash of the message? Okay, so RFC 9909 registers, interestingly enough, both the SLH DSA and also the hash SLH DSA, which is, as the name indicates, it just sort of produces a hash first and then signs the hash. The idea is that by doing this second variant of the algorithm, you don't need to pass in potentially large payloads into the cryptographic algorithm implementation to sign it. In the COSE SLH DSA draft, we currently only use the pure version of the algorithm, and of course that reduces the size of the implementation because there's only one variant to implement, but it's possible for some that we miss something out here. Next slide. So what did the RFC 9909 say about why it includes the hash variants? There it says that there are larger payloads, such as X509 certificate sizes, and also CRLs, which may require that implementers pass in only a hash. And also talks about hardware security models that also sort of ideally operate with a high speed. So clearly you have to pass in, if you don't support that form of algorithms, then you need to pass in sort of the whole buffer instead of just a smaller version of it. That's why it says it does this. This sounds a little bit like what we would really want in COSE as well, but I'll get to that in the next slide. Next slide. So in COSE, of course, we focus on smaller, more interoperable profiles, but interestingly, we have one specification which is currently being finalized, which is the hash envelope, which is, if you remember that specification, it allows to sign a digest instead of the original payload, not just for the SLH DSA algorithm, but in general. So it is a little bit a different design, but it, at least from a conceptual point of view, it kind of does the same. So that's an opportunity in COSE, which doesn't exist in Jose, and in my opinion, doesn't exist in the BKICS world. Okay, next slide. A few words about why this hash envelope is a little different. Like as I just said, it's a generic construction. I think Ori and Hank and some others are the authors of it, and it was discussed in a group extensively. It's also it's obviously not part of the NIST FIPS specifications, but instead just it's a result of this working group. So it's very similar, but not obviously semantically identical to the hash SLH DSA work. Next slide. There are potential arguments for registering also the hash SLH DSA, and one is, and I think that's the last item on this list, is because for Jose, there's no specific, or there's no hash envelope counterpart, but since it was only defined for COSE, so that may be something to think about whether this is needed also in the Jose world. But since so far I haven't seen anyone bringing this up, it may not be a big concern, and maybe people are not worried about the size of the messages, given that SLH DSA itself already requires a fairly large buffer size because the signatures are quite long. Okay, next slide. Yeah, that works. On the negative side on why the SLH DSA is not registered, it of course adds, if we support this, it basically adds another set of algorithms, because we then have to support all the variants also for the hash-based version. Maybe only for Jose, but nevertheless, so it's not really, can quickly blow up the registry as well. Next slide. So currently, so obviously there are a couple of options. So currently, I would, so the three obvious options are do not register the hash SLH DSA, and the other one is to obviously do it, and the third option is to register it later. My preference at the moment is to just defer the registration if someone really needs it, or at least for all of you in the group to think about whether this is really something you consider using specifically in Jose, whether that's a real concern. I think the hash envelope in COSE is just fine. So I think it's good. I see Carsten saying something different, but that's exactly the intent of sort of like going through these design decision again, so that we actually know that we are still have the same opinion as maybe a year or so ago. Okay, next slide. So there's also another angle to these registrations, so that different security levels as well. It's not just the hash SLH DSA versus the regular one, but there's also the dimension of the security levels between 128, 192, and 256. Currently, the document aims for security levels only of those security level 128 and omits the others. And yeah, as a starting point, obviously 128 is a good start here. But and particularly with SLH DSA, as I mentioned, I only included a single example because of the length of the signature. And if we extend that to other levels, obviously the signatures get larger, and there's some complexity in there as well. Next slide. Yeah, it's the other ones haven't been omitted because they have any sort of like negative security aspects, but it's really about keeping the numbers, the registered code points, small rather than anything else. But of course, if you have use cases which require these other levels, it would be good to know about them. Next slide. Then to make things even more complicated, there are also different variants called S and F. S, as I wrote here, for small signatures. Small is relative in this algorithm. F is for fast signatures. So there's a difference, like for the lowest security level, the 128 of signatures of the size of, let's say, something around 7,000 bytes for S and 17,000 bytes for F variants. So clearly there's a difference. So it's not just a minor detail, but then there's also the computational aspect there too. Currently, the document registers both or algorithm from both variants for the 128 size, just to have sort of the different performance characteristics in there. For COSE type of deployments, so the constrained IoT deployments, of course, you would really want something that is both small and fast, but I guess that's just wishful thinking. And so for many deployments where the bandwidth constraints dominate, small is probably a good choice. And of course, unfortunately, some of the devices also have limitations on the computational side. But yeah, so you have to decide which characteristic is more important to you. So there's clearly a trade-off here. Next slide. So that the two variants are there, but maybe only because of the size reason. Maybe the small one is more important to some of you. I said all of that already. Next slide. So I will drop a mail to the list, ask these questions again, and maybe you have a look at it. Look at the three algorithms that are being registered for COSE and COSE. Both are kind of mirrored, and obviously it would be good to know whether you see some differences in the different deployments and want to adjust the list of registered algorithms a little bit more. But if you're all happy with the choices we've made in the past, then I think the document is quite good. Maybe I'm going to provide, or maybe someone else provides the test vectors or examples for the COSE variant, and then at least the SLH DSA version could be finalized. As we said in the meeting, I think November meeting, we wanted to progress the COSE FN DSA a little slower because we are waiting for NIST to finalize all the work, but I think we're still on that same path. I've been talking to the BKIX team working on the interrupt tests, and there was also some interest to do interrupt tests, not just for the BKIX BQC algorithms, but also for the COSE ones. So this is definitely something I'm going to pick up. And if there's someone else in the room who would like to do some interrupt testing, who has some implementation work going on for these two algorithms, please reach out to me. And I see a line has formed.
There is a queue.
Yeah.
Let me take the queue, and then actually I'm going to ask a clarifying question to get it on record before I take the queue. Is it the case that the underlying NIST specifications for SLH DSA are final, whereas the FN DSA NIST specification is not final? Is that correct? Any experts speak up?
Yes, that's correct.
That's right.
Okay, thank you. With that, I will go to the queue. Karsten.
Yeah, I said I prefer option 2.
when we decided to not go for polymorphic registrations, for registrations that where one algorithm number covers a number of parameter sets, we also decided for combinatorial explosion. So I cannot take arguments very seriously that we want to keep this algorithm registry small. I mean, look at it. There's no way we will keep it small. Of course, we shouldn't put fluff there, but the hash issue has come up repeatedly. So I would prefer to just put these things in. In practice, what happens if we don't put things in is people will see that, and if they actually did plan to use this algorithm, they will just decide, oh, COSE is not for me, I'm going to use ASN1 or whatever. And that's not necessarily an outcome we want to have.
Thank you. Scott?
Mute. Okay. Scott Fleur, Cisco Systems. I am actually new to COSE, so take that in mind. As for, I would take the opposite approach. I don't know how common support a hash SSL HDSA will be to various crypto modules, so I'd be hesitant to actually to support it, because quite frankly, I don't know if the underlying crypto will in the future. However, what my main point I wanted to point out is that this hash versus pure question will likely be repeated in the FNDSA, which has precisely the same issues. And so what, again, you probably will come up with exact same answers, whichever it is. You have to keep that in mind. Thank you.
Thank you, Scott. Philip?
Thank you. Hi, Hannes. For COSE SLHDSA specifically, I think, first of all, I appreciate that the number of algorithms is kept down. I think there are 3 at the moment. Correct me if I'm wrong. Even though there is a much larger parameter set available, so it's not like we're trying to register everything. The thing that I'm not sure about is the general applicability of this over MLDSA or in the future FNDSA, where the small signatures are slow and the fast signatures are not fast enough. So I would like to know whether you intend for this to be a general purpose signature scheme for COSE, or whether this is intended for a particular use case, such as signing firmware. And in that case, is that something that COSE is meant for, rather than just COSE?
Yeah, I can quickly respond to you, Philip. Thanks for the comment. The SLHDSA, as also Jonathan mentioned on the list, is definitely a good contender for securing firmware updates already now. So that's I think that's also why the NSA has sort of like looked at these hash-based variants for firmware updates. So I would say it's definitely not a generic mechanism, BQC mechanism, but in that, for that use case, I think it's a good choice, because firmware updates are in general large, so the larger signature is sort of like kind of disappears in that larger payload anyway. For the FNDSA, it was developed as an alternative design to some of the other algorithms. So it's kind of a backup choice. And with that, I assume that the primary choice, MLDSA, would be used sort of maybe more often, or is likely to be used more often than the FNDSA. But I'm like,
I
it's
think
fine
the
otherwise.
barrier for entry to Falcon is the complex floating point arithmetic, which is not there for MLDSA.
True.
But time will tell how often this will be implemented in underlying crypto modules. But
Yeah,
as you
definitely.
said yourself, FNDSA is quite a way out. I haven't heard any updates since, I don't know, a year and a half ago. So
Yeah. Well, there's also
I think
another competition ongoing. We'll see those this work, and of course, only time will tell on how we are going to use or see the use of different algorithms potentially in combination with the traditional signature algorithms. So it's going to be interesting. Yeah.
Thank you, Philip. Tiru.
Hey, thanks, Hannes, for the excellent presentation. So I have few comments on the use of uh, uh, SLH So if you look at firmware updates, right? I mean, we typically are currently relying on hash-based stateful signatures. The only alternative that we have, if you want to migrate, is which offers the same level of security, is SLH There's no way that we can use MLDSA because of the uncertainties with the lattice schemes, and that's the reason we have composites, right? So for suit, I believe the two only viable alternatives is either go to stateful hash-based signatures or pick SLH or I don't think you will be able to deploy ML pure MLDSA, especially because of the non-repetition issues. Um, and do you have any comments on that? How you want to take that forward?
Good question. Would have to think about that. Do you have a suggestion?
I think at least we are planning to use pure SLGSA and not go with MLDSA or the Falcon one because of the lattice-based schemes, because that would not give us the properties of non-reputation. So the, either we have to stick with stateful LMS or XMSs or go with SLHDSA. But then it has a challenge that we'll have to look into the signature sizes and public key sizes and see if it fits within the, the memory that is available on these constrained devices.
Yeah, it's maybe we should also reference some of the work in the BQ group on some of those aspects. I don't think we've done that because there's also like as your course on some of the document which discuss some of these aspects on for constrained devices and also the dealing with the stateful nature. There are also other documents that talk about those. Maybe we should reference them.
Yeah, that would be great. And coming to the options, right? I mean, as far as I hear from the LAMPS working group, the hash-based SLH seems like not a favorite one that the CA community wants to deploy, basically, right? So I think we better cross-check once, basically, right? I mean, if there is I mean, hash-based SLH has an advantage. It pre-hashes, right? So you basically send a small size of a hashed message to, let's say, HSM to sign the message, which gives you a much better performance than sending very large messages, right, to the HSM, right? But I think it's all about deployability, right? I mean, if there is a good interest from the community to implement and deploy that, it makes sense. But otherwise, if there is not, then I think we need to probably explain why it is required and get it to a state where if you really see that makes sense to add it or not. But at least hash-based SLHDSA, we did not register that we are not using that in the IPsec.me or the TLS drafts that we have. IPsec draft is adapted by the working group. TLS is still working. TLS also we did not do register code parts for that. So, but I see the advantages of that in this case because of the pre-hashing that is there. That probably requires some more discussion in the working group on on the feasibility and deployability and whether there is interest to implement and deploy that.
Okay, thank you, Tiru. I'm going to give the cue to John, and then I'm going to run 2 polls.
Yeah, hi, it's John Gray from Entrust. I was just going to say the SLH DSA, there's the NIST does have the smaller parameter sets that they're coming out with. If constrained size of signatures is a concern, that's something you could look at. Yes, they might have slower signing times, but again, I guess unless you know your use cases, you're not sure maybe which ones exactly you're going to need. But so there's that, and I agree with what Tira was saying as well about the signing of like with CAs. Like if we're trying to sign large CRLs with SLH DSA, it's like the pure mode is very difficult because the whole thing has to be kind of in memory, whereas the hash one works. But then, there's issues with the operational. Obviously, they can be worked around, but that's just, again, I agree with that consideration as well. Thanks.
All right. Thank you, John. I'm going to solicit working group input now on the question of whether we add hash SLH DSA to the draft. The poll is running. There are 52 of you here and or 54, and we have less than half that many responses. Even if you give me a no opinion, please respond in the tool. All right. By more than a factor of 2 to 1 among those with an opinion, we're not going to do that. We're going to stay with the scope of the draft as adopted. People can discuss that on the mailing list further if they would like. So that's that. With that, I'm going to ask the question, do people believe it's time to take the Sphinx Plus draft, also known as the SLH DSA draft, to working group last call at this point, given that the NIST algorithms are stable?
So while we are waiting for that poll to complete, I'm not so happy about using voting in the IETF. You're counting votes, and then you say, oh, so we don't need that. Well, the reason may be that a lot of people are in this room who actually do not need that, which is totally fine. We can register things that some people don't need. Just pointing out that your methodology is not really very good here.
I hear you, Karsten, and let me respond with chair hat on. By default, as chair, I'm going to respect past consensus decisions of the working group. The consensus decision I'm referring to here is the decision to adopt the Sphinx Plus draft with a particular scope that Orion, Hannes, and others have continued to pursue. In my view, it would take a working group consensus to expand the scope for us to decide to do so. I'm not basing what I said earlier on a vote. I'm basing it on evidence that there is not apparent working group consensus to expand the scope of the draft at this time. That's another thing that could be taken to the list. And if you want to make that case, feel free, but there's not, I don't have any evidence of working group consensus to expand the scope today. All right, I'm going to end this poll. It seems like there is substantial support for taking it to working group last called. Any of the three people who were not in favor of that want to join the queue and say why? John?
Yeah. Sorry, John. I just said it just based on that. I know there's these smaller parameter sets coming for these algorithms. Now, I mean, I guess those could be done in a different draft if you want them, and then I would change my opinion. I just thought, I guess, like if they're coming soon, I guess the thing is it's on this time frame, so I guess we can never know when, because they say things are coming and then they don't. But that was my concern, because I noticed this like the 128 one, so obviously size is a concern. So if we know there's these smaller size ones that are coming out that would be useful, then can we not just wait for those, or should they be in a different draft, I guess?
Thank you, John. Scott?
Yes, about those smaller parameter sets. So they are very preliminary. The 128 versions are around, I think if I remember right, around 3K in signature size, but they may be changed. They're just initial drafts, initial proposals. This very well may change their minds. In fact, in some ways, I hope they do, because I think they could be improved somewhat. I think it'd be very premature to actually endorse them. Thank you.
Thank you, Scott. Anyone else? Okay, I will confer with Evo afterwards, but it seems like we may be preparing for a working group last call. Thank you, Hannes. That was super useful.
Thank you, Owen.
Okay. All right, looking at the agenda, the next draft up is the COSE HPKE draft, where I will be the presenter, but not as a chair, but as a draft author, and I'm giving control to the clicker. Good morning, or other appropriate greetings, depending on where you are. Let's try again. Good morning. I'm Mike Jones, an author of a working group draft, giving a presentation for which Evo is chairing. So we've been working on COSE HPKE for a while. And much like the COSE HPKE, I believe we're finally at a really good place. So in Montreal, we presented draft 18. Since then, based on feedback from the working group and editorial review by some of the editors, in particular Lawrence, there's been a flurry of updates published, which we've described on the list. The most recent draft published was 24 on the 15th of March. There are 3 implementations that were used to validate the examples, which I'm very happy with. So what have we done? The big change was to use fully specified algorithms rather than polymorphic algorithms, in line with the approved fully specified algorithms RFC. We made a lot of clarifications to how the AAD and info HPKE parameters are used. And we have clearer handling and description in the draft of how to use application supplied additional authenticated data and context information as inputs to the HPKE process. We defined the recipient structure for doing those things. We tightened the rules around what things must be in protected headers when they appear so as to increase interoperability. We clarified the key representation. We updated a lot of examples, I think all the examples. We added test vectors. I got added by the other authors as an author by virtue of the amount of work I was doing on the draft, which I appreciate. So let me drill down into a few of these things. The introduction of the separate algorithm identifiers means that we have different algorithms for use with HPKE integrated encryption mode versus HPKE key encryption mode. Again, this is to use fully specified algorithms. We also added at Apple's request the HPKE 7 and 7KE algorithms using a particular set of combined HPKE parameters. So the recipient structure. It contains a constant string, the next layer algorithm, so that this becomes cryptographically tied to the next COSE layer. There's the recipient protected header is included, again, to protect that. There's the recipient extra information so that you can add stuff if your application needs it. We clarified that the COSE KDF context is not used, and there's security design rationale in the draft that explains all of this, the reasons for it. Deterministic encoding is needed to be used for the recipient structure because it is not transmitted. It is constructed by the two parties independently. Therefore, if they don't construct it in exactly the same way, it will not cryptographically validate. So there is deterministic encoding used for that structure. It is not used for other things. The AAD handling. For integrated encryption, the HPKE AAD contains the serialized COSE ENC structure. There's a context string. The external AAD must be the external AAD field. For key encryption, things are done a little differently because you're not doing everything in one layer. The HPKE info is the recipient structure. The external context, if any, goes into the recipient extra info. Recipient additional authenticated data is generally not necessary. And any large external data should go and be protected at layer 0 using external AAD. All of this is well explained in the draft, thanks to numerous authors wordsmithing this text. This was the primary textual change, other than the examples made in the draft. And as an asterisk, I'll note that all of these are essentially the same choices that Jose made, to the extent that the same choices make sense given the layering is slightly different. We sharpened the processing of the header parameters. We say where EK must be. We talk about protecting the algorithm in the COSE recipient, that the use of KID is recommended, and that we recommend placing the KID in the protected headers so that it's covered by the HPKE key derivation context. So the key representation, if the key type is AKP, then the key material must be the raw HPKE key for the corresponding chem. And there's validity rules for various key type and curve combinations, including the use of key ops. There are examples of everything and test vectors for everything. Thanks especially to Hannes for doing the heavy lifting of this, but also to Daisuke and Lawrence and Ori for writing code that enables us not only to do this, but to believe that we got it right. So in conclusion, the authors unanimously believe that the specification is ready for publication, having completed working group last call and successfully addressed all known issues. Ivo, you're chair.
Yes, I agree. I have started writing the Shepherd write-up, and once I have uploaded it to Data Tracker, I will request publication.
All right, thank you very much. Is there a queue?
I don't see anyone yet, but yeah, if anyone wants to speak, please do it now.
This will go on record as the first HPKE presentation in this working group without substantive discussion. I feel like we've achieved something. Thank you. Okay, I'll end this deck, and I believe I'm doing a different deck.
I see some. Okay, so that's for the next presentation, or?
Yeah, I just wanted to thank the Jose HPK authors and the entire working group for making progress on this. I think it's a significant milestone. So I don't have any comments, but it looks ready to ship it. Thanks.
All right. I believe that the next presentation scheduled was for Tiru, but no deck was ever uploaded. Am I correct, Tiru?
Yeah. So Mike, I had sent a mail a few days back on why I didn't want to present this in light of the discussion in the Jose working group. Right. I think the chairs and the AD had a comment that we need to work on a unified mechanism on how we want to take this forward for both COSE and Jose. And the plan is the authors of both the drafts are going to work on realigning these drafts in a way that we, wherever possible, we will align, and wherever not possible, we'll figure out why we cannot align and give justifications for that, and come up with new specs, either one spec or two spec. So I didn't see a need to present this at this time, because eventually, again, it has to go back to the small design team to figure out the best way forward.
Okay, thank you very much for that context. Does anyone want to speak to Tiru's points? Okay, hearing none, I'm going to pass control to the clicker and be another author. In this case, I'm an author of an individual draft you've heard about for the last 3 IETFs with my colleague in Sweden, Emil Lundberg. This is the split signing algorithms for COSE. So when we last met our heroes in Montreal, we gave a fairly substantive presentation of what the draft does and why it does it. You've heard this before. You could read it again. We're not going to go over the what, why, how, or the context of the work today, unless you want to bring it up from the mic line. So what's happened since IETF 124? We got great reviews from Lucas, who is also our scribe today, from Sophie, and from David Dong of IANA. What have we done to the draft since that? We have incorporated their feedback and confirmed that the authors were happy with, or that the authors of the reviews were happy with what we did with their feedback. So I'll now talk about what we did. In draft 4, we described implementations that exist. In draft 5, we made a bunch of clarifying comments in response to both Lucas and Sophie's reviews, which I'm not going to read these. This is all text straight out of the history section in the draft. So you could go read it yourself or look at the presentation if you like. And again, draft 5 was where we did the bulk of the work to respond to the useful reviews, which were requested in Montreal, and both of the volunteers did do the work. Then a few days ago, IANA, in the person of David Dong, who I met for the first time ever at the new participants reception last night, did an early IANA review. And he correctly pointed out that some of our IANA considerations sections were still listed as TBD, even though we knew what needed to go there. And so I thought, well, this is silly. I will populate the IANA considerations sections. That did happen in the last 48 hours. It changes text that used to say TBD to defining the registries and populating the registries with values that were already in the specification. The other thing that was done as part of draft 7, besides populating the registries, is some of the algorithms being registered are ARKG algorithms, which come from a different draft that was presented to the CFRG by Emil a few days ago. We're going to see if we can get an adoption call for that, but that's not our topic today. Nonetheless, an editorial action was made to import some of the text from the CFRG draft that would be appropriate to be in this draft. No normative changes were made, nor no animals were harmed in the process. So what did we do since Montreal, in summary? We improved a number of explanations in the draft and provided more rationale for why the draft exists. We added more background information on existing uses of split signing, especially uses of split signing for smart cards, which our use case is very analogous to that. We did list implementations. There are multiple. We did populate the IANA considerations section. There's no more TBDs in the draft. There were no architectural changes made. So my assessment as an individual author, and I believe Emil concurs, the draft is stable and clear. It incorporates review feedback from the reviewers. It meets the needs of a real and important use case. In particular, the WW Wallet, cloud wallet from the Ceros Foundation, aka Ceros ID, was one of the entrants in the German Funke wallet competition and one of the winners, but it depends upon the ability to have split signing, and it also depends upon a WebAuthn extension that's not final that some of you are aware of. So like many standards-based activities, we're assembling the building blocks to make this use case and potentially others standards-based. This building block is in COSE. So at IETF 2024, the decision of the chair, Ivo, which was a good one, was let's get some more reviews and then consider adoption. We got good reviews, we respond to them. I think adoption should now be considered, but Ivo, it's your chair role to decide.
Yes, I think based on the feedback, we are ready to run a call for adoption and confirm it on the mailing list. Of course, if anyone has comments now, please share them. Otherwise, that will be my my plan.
All right, thank you all. All right, back to being a chair. The next draft, which was requested to be presented, was Draft Lemon's COSE composite claims. Chris, are you there?
So I checked, I guess that was requested somehow for last ITF, and I have made the mistake. I didn't find at least the email for Chris requesting this presentation. So probably that's my mistake.
Okay.
The next one though, so the next two, well, I saw the email for the CMAC, so I don't know if Brian is there, and Alexander Pelov was requesting more kind of, well, basically was asking, hey, what would be the next steps for this draft? Let's have a discussion. So it was not explicitly saying, well, we need 10 minutes for this draft. I just gave it so that we can figure this out. But maybe somehow that got missed in the communication. I don't know. Okay, I see the
All
scene.
right. Brian, you are up.
Okay, thank you. This should be short, and it's really a question to the group. So can you go to the next slide, please?
Oh, I just gave you
there we
control
go.
of the slides.
Perfect. Thank you.
Okay.
So I'm going to be talking about the family of CMAC algorithms that I'm looking at adding as registrations for COSE. And a little bit of background is that there already are registrations for similar family CBC MAC algorithms, and there's nothing functionally wrong with these things, but they are not approved by FIPS 140, and that is a bit of a gate to using them in certain applications. And the use of NIST cipher block MAC is FIPS approved, and AES CMAC in that mode is already something that's part of existing IETF behaviors and IEEE behaviors and some others. And there was actually mailing list discussions several years back about what to register initially for COSE, and it was going back and forth between CBCMAC or CMAC, and there really wasn't a conclusion. So it was, I think, just kind of arbitrarily chosen to be CBCMAC, and that was even before some of these conformance requirements had been made. So it was not a bad decision. It was just an arbitrary decision, somewhat. So that being said, I have a personal draft that does a very simple registration of these AES CMAC algorithms, only 2 of them with 2 different key lengths and maximum tag length. And these are intended to be used in a kind of a hardware accelerated authenticator type of situation. And the expectation is that this is going to be used in that kind of environment where it's high throughput, high volume. And there was some discussion that I reached out to the Jose group, and they were not interested in this kind of thing just because they're not targeting the same kind of applications. So moving on then to the real questions to the group are that there's a standard action constraint for registrations algorithms between plus and minus that 2-byte encoding, and there's many of them that are currently unregistered, and it seems like to me doing this registration through COSE working group seems natural. There's no customization happening here. I don't think there's any kind of security analysis that needs to be done. So the question is, does this seem relevant for the working group? And does the current draft seem like it's on the right track?
John.
Hi, I disagree with that it was not a bad decision. I think it was I'm baffled by COSE standardizing CBCMAC. So I think just publish this. It's well-known algorithms. There's not much to discuss. Just publish the RFC, register the code points, and made the old CBC MAC not recommended.
Okay, so that is actually a separate question. This original draft was just registering these code points without touching the CBC MAC, but if there is a feeling about CBC MAC transitioning into not recommended, that's an additional consideration, I think. And I don't have strong feelings about it. My goal is to be able to use CMAC, and if there's other concerns about the CBC MAC, I'm welcome to talk about them.
So in the chat, Russ supports adding AES CMAC. Karsten does. Adam does. Although Russ says do something with AES CBC MAC separately.
Yeah, I'm perfectly fine with that. And there's no real overlap. They're 2 separate families. They're 2 separate sets of algorithms, and they don't need to relate to each other.
Okay.
In terms of documentation.
Well,
Okay,
I'm gonna go ahead.
Okay, Scott Fleur, Cisco Systems. Given the choice between CMAC and CBCMAC, I would always go with CMAC because CBCMAC has some known cryptographical weaknesses, which you can, by various, you can potentially generate forgeries, which that weakness does not apply to CMAC. is those particular methods critical for COSE? I do not know. I do not care.
Yeah, thanks about that. And there are, like you said, there are special considerations for CBC Mac that I know are part of the existing documentation, that there's a kind of a workaround in how COSE uses them. But for the sake of a draft and the documentation, the intent here is just to say CMAC is its own meaningful thing, and we want to register it. So thanks for that feedback.
Does anyone else want to join the question queue? All right, well, I will ask probably my most asked chair question. Who has read the draft? I see no one in the room. Are there people who can add to the chat that they have read the draft?
The good news is that it's very short.
The draft is very short. All right, I will ask my standard chair follow-up question to that question. Most of you know what's coming. Who is willing to volunteer to read the draft? I would particularly covet reviews from people who have opinions and familiarity with the underlying cryptography. So going out on a limb, Russ, would you be willing to read the draft? John volunteered. Russ said, okay. John Pruce-Mattson, would you be willing to read the draft?
Yes, and as I wrote in the chat, I have already read it. I can read it again.
Oh, okay. Thank you very much. So I look forward to reviews on the list, to seeing updates made to the draft as a result of the reviews, much like Emil and I did with the previous presentation, and then we will go from there.
Thank you,
Brian. With that, I believe we are at the end of the scheduled presentations. It's now open mic time. And Ivo, is there anything you would like to say to the working group?
No, I think outside of what we already discussed, nothing really.
All right, hearing none, let's thank Karen and Lucas again for taking notes. Appreciate you being here, both physically and virtually. And as they say, we'll see you on the list. Thank you. Bye-bye.
Thank you.